you have been working so hard to better understand fractions, how they relate to each other, and how to add and subtract fractions. Let's use this as a quick review video just to sharpen some of your understanding. Here's item 9. It says write two fractions that are equivalent to 8/12 and then draw a model with split fraction bars to justify your answer. Now, one of the things we learned is you can use a multiplier or a divisor to create equivalent fractions depending on the fraction. In the case of 8/12, we could use either. Let's look on the left. Let's use a simple multiplier like 2. If we do that, 8/12, we can show the equivalent of 16/24. Now that's Taco Bell math. It's a shortcut. What is it going to look like when we try and go to the model? So here's a model of 8/12 in my classic awesome artistic rendering. Remember, when we use a multiplier to create an equivalent fraction, we are really splitting each unit by that many. So here, if we're multiplying by 2, then the first 12th, we're going to split 2 ways. And every 12th after that, just pretend that I can draw super straight and mathematically awesome lines. Every 12th after that. And fractions are all about equal sized parts, so even the ones that aren't shaded to show the numerator get that split in 2. Now if we recounted, we'd see there are 24 equal spots and 16 of them are shaded. That's the model. That's what's happening when we use a multiplier to make a more complex equivalent fraction. But what about when we use a divisor? Well, let's use 2 again. So here, we're going to divide both the numerator and the denominator by 2, because with equivalent fractions, it's always the same one for numerator and denominator. Well, our quick drive-through math tells us 8 divided by 2 is 4, 12 divided by 2 is 6. And 4/6 is another equivalent fraction. Great, but what's it going to look like when we look at our model? When we're dividing by 2, what's happening is we are actually going through and creating new groups. We're grouping by 2. And showing this here is a little bit tricky, but let's say I do it this way. I'm going to take that 2 and we're going to make it 1. Take this 2, make it 1. Take this 2, group it into one chunk. This 2, group it into one chunk. And just like before, even the non-shaded ones, because fractions are equal parts. Now, how many parts do we have? We have 6 parts. And how many of those parts are shaded? 4. So, we see both the mathematical modeling and we see a quick shortcut to show us what are equivalent fractions, how do they relate to one another. On to question 10. Now, question 10 really has multiple parts. And it asks you to draw a line to match a fraction from the left column with an equivalent mixed number on the right column. So what are we going to do here? We're going to convert this fraction greater than 1 into a mixed number so we know what to pick. Let's see, 11/4. You can see little stick figure person thinking over here on the side, and they are showing a picture that shows 11/4. Count them up. All those green parts are 11. How do we know they're fourths? Each whole is broken into 4 equal pieces. That's what we're counting in. Now, if I want to break this apart, I want to break it into parts that will equal 1 whole. And I could see we've got 4/4 that'll equal 1 whole. That leaves me with 1, 2, 3, 4, 5, 6, 7/4 left. That means I can make another 4/4. There's another whole. What do I have left? Well, if I've got 4/4 and 4/4, that's 8/4, which means I've got 3/4 left that I can't turn into a whole number. So let's continue simplifying. I know that 4/4 equals 1 whole. And so both of these, I'm going to use their whole number equivalent because I'm trying to simplify this into a mixed number. Now I just simply have to add 1 plus 1 plus 3/4, 2 and 3/4. And sure enough, it's one of the choices that you can make a link to. Now that you've done this, you've just got to finish the other 3 in that part. Same exact strategy. Give it a try. All right. I'm going to pop over to 11B. And remember, if you're watching this straight through, you don't have to. You can pause and work on what you're going to work on. And when you get to 11B, that's when we can work on it together. All right, if you're here with me, the directions for 11 say choose yes or no to tell whether the fractions are equivalent. So here they give us 2 fractions, 16/18 and 8/9. And what I'm wondering is, can we find a mathematical rule, either a multiplier or a divisor, that works for both? Remember, it's got to be the same, because that's how equivalent fractions work. We're either making bigger pieces or smaller pieces. 16/18, those are small pieces. Let's look at the denominator. To get from 18 to 9, I would have to divide by 2. 18 divided by 2 is 9. 9 times 2 is 18. That works. But will the same rule work up top? Let's see. 16 divided by 2 is 8. 8 times 2 is 16. Are these equivalent? Yes. 8/9 are just bigger pieces that still show the same value as 16/18. That's what we're doing here. You can look for a common divisor or common multiplier to see if you have equivalent fractions. If you can't find the common divisor or multiplier, that probably means they are not equivalent. All right, I'm jumping over to 12C, where we are subtracting mixed numbers. We've spent a lot of time working on this over the last week and a half. Let's walk through. The first thing I notice is my denominators are different. I need the same size units or pieces if I'm going to be able to count these together. So I've got to create some equivalent fractions. I know that means that I've got to look for a common multiple. The best common multiple that I'm going to be able to find will be the least common multiple, because it'll mean easier work. Looks like that's going to be 20. That makes sense. 5 times 4 is 20. It'll work. Now I've got to create equivalent fractions. To get from 4 to 20, I'd have to multiply that 4 by 5. If that's what I do to the denominator, yep, I have to do the same to the numerator. And there I've got one equivalent fraction. To get from 5 to 20, well, 5 times 4, right? And I have to do the same to the numerator. Now I have 12/20 take away 5/20, and 3 take away 2. Well, we're gonna subtract the way we would, kind of in a place value way. Fractional part first. So let's see. I think 12 take away 5 is 7. Let me just make sure. 7, 8, 9, 10, 11, 12. Yep. Oops, what am I writing? Ignore that part. I just repeated writing there we go. I said 7 and then wrote a totally different number. Ah, well, let me try again. There we go. And 3 take away 2, 1. Got to remember that whole number part, because it's all kind of one chunk of number, right? 1 and 7/20. Now I have to ask myself, is this in simplest form? Well, I know dividing by 1 wouldn't change anything in the numerator and the denominator, and 2 doesn't go into 7, and 3 doesn't go into either one, and 4 doesn't go into either one, and 5 doesn't go into 7, and 6 doesn't go into either one. 7 goes into 7, but not 20. And beyond that, I just can't think of anything. So I think we're good to go. 1 and 7/20 is an answer that makes sense, and I can show my work to explain my thinking. Moving right along. I'm going to jump to number 15. We're not going to have much on the test as far as estimating goes, so please don't panic if you feel a little bit shaky on this. It has a problem that says Ika mixes 6 7/8 pints of grape juice and 4 1/4 pints of cranberry juice to make punch for a party. She has 9 pints of punch left at the end of the party. Estimate how much punch Ika served at the party and explain how you estimate it. The cool thing about estimating is I can kind of get rid of these fractions if I want to and go with just whole numbers. In this case, that's exactly what I would do. I would say, okay, Ika mixed about 7 pints of grape juice, because 6 7/8, that 7/8 is so close to one more, with about 4 pints of cranberry juice for the punch. Why 4 instead of, say, 5 or 4.5? Well, 4 1/4 could go to 4.5. I've decided to bring it down to 4. That means that the total amount of punch she started with was 11 pints. You know how much I love a label. But that doesn't answer the question. It asks how much she served at the party. Now, the problem when we go back, if you go back and reread it, and I sure hope you have it in front of you, it says that she had 9 pints of punch left after the party. So she started with 11. She still has 9. About how much punch did she serve? About 2 pints. And how did I estimate? Well, you can see how I've rounded the numbers and how I used that to come up with an answer that I think makes sense. I hope this was helpful. Again, do not bang your head against a wall about this estimation stuff. We'll keep coming back to it again and again throughout the year. All right, you've got this. Now keep working and be ready. You can do it.